So now, is there any doubt in this example? Shall I go to next? Is there any doubt here?
No, sir.
Okay, we'll move to next. Here again, f of n and g of n are asymptotically positive functions. Now the first one, f of n is big O of g of n implies g of n is big O of f of n. What does f of n is big O of g of n mean? Order of growth of f of n is less than or equal to order of growth of g of n. It is given. It is given. Then what is that they are asking? Which implies order of growth of g of n is less than or equal to order of growth of f of n. Is this true or false?
Sir, it is like may or may not be. We can't say it is completely.
So may or may not be means at least there is one example for which it fails, no madam?
Yes, sir.
That means our answer should be true or false?
Their answer should be false because there is example.
False. So answer should be false. So can you give an example where it fails?
So when fn is
Fn is, if we take n square, g of n as n power 4. N power 4. Okay, then what is that they are asking? N power 4 less than or equal to n square. Is that true? Is that true? It doesn't hold, no?
False.
It is false. So that means counter example 1 is sufficient. So hence it is false. It is false. What about second one? F of n plus g of n is theta of minimum of f of n comma g of n.
True, sir.
So one example if we take f of n is n square, g of n is n cube. Now what is f of n plus g of n? N square plus n cube is same as theta of minimum of n square comma n cube. What is minimum of n square comma n cube?
N square.
So now, is this true? Is this true or false?
False, false.
So this is counter example, no?
Yeah.
Or based on the definition also easily we can conclude here. Because f of n plus g of n means definitely whichever is more, that much order of, what is final order of growth of this? What is order of growth of this?
Maximum of
f of n comma g of n, no?
Yes, sir. Yes, sir. Yes.
Maximum of g of n comma f of n. Is that okay? Now, so answer is true or
false? False.
Answer is false. If our question was something like this, this is also false. If our question is, if it is something like this, is this true? Is this true in this case?
Yes, sir.
F of n plus g of n is theta of maximum of f of n comma g of n.
Then it is true.
Is this true? So that means n square plus n cube. No, this is theta of n cube. This is say f of n. This is g of n. So something like this. So finally, what is order of growth of f of n plus g of n? It is maximum of this. So whatever is given here, it is also theta of this. So hence it is true or false? It is true or false? This is true. This is true. instead of this, if it is given big omega of minimum of f of n comma g of n, is this true or not?
Yeah, it is true.
Is that true? Because its order of growth is same as maximum of f of n comma g of n. Here they are saying it is greater than or equal to this. Definitely it is true. It is greater than or equal to this. Hence it is true. Is it same as this? Minimum of f of n comma g of n. That is,
It is also true.
is this true?
Yes.
Is that true? Is that
Yes.
true or not? So for example, if I take f of n as n cube, g of n also as n cube. If I take f of n as n cube, g of n also as n cube. Then what is order of growth of f of n plus g of n? What is order of growth of f of n plus g of n?
Yeah, n cube.
N cube. So that means
Yeah,
n
it is
cube,
false then.
n cube plus n cube is omega of n cube. Is this true?
No, it is false.
So it's a false. Hence this is false. This is false. So if I write it like this, it same thing. F of n plus g of n is little o of maximum of f of n comma g of n. Is that true or false?
No, it is false then.
Is it false or not?
It is
True,
false.
sir. True, sir. It
It is
is strictly.
No, false because equality is there. No, the
If
same
equality-
example will be false.
If f of n and g of n both have same order of growth, it fails, no? Other cases it is true. But if f of n and g of n both have same order of growth, it fails. Same order of growth, it fails or not? Is there any doubt? Okay. So what about third one now? Is that true or not? F of n is big O of g of n. So that means what is given here? Third one, order of growth of f of n is less than or equal to order of growth of g of n, which this is given. This implies, which implies something. Okay, no? This is that true or not? Is that true or not?
Yeah, it is true.
True, sir.
True. Okay, let us take f of n as 3n, g of n as n. Let us take f of n as 3n, g of n as n. Whether the first condition is satisfied, order f of n is big O of g of n.
Yes, sir.
F of n is big O of g of n. Is this true?
True.
It is true. That implies, what is that question given? 2 power f of n, 2 power 3n, 2 power 3n. Is it same as big O of 2 power n?
No,
Is that true?
no.
Is that true? Because what is order of growth of this 2 power 3n? This can be written as it is same as
8 to the power n.
2 cube whole power n, which is same as 8 power n. 8 power n. 8 power n, is it same as big O of, is it big O of 2 power n?
No, sir.
No, this is false. That means for there are, for if we take for some functions, no, it becomes true. But there is at least one pair of Fn and Gn for which it is failing, no? Hence, final answer should be true or false?
False.
False. Now, what about fourth one? What about fourth one? F of n is big O of G of n implies log of F of n is big O of log of G of n. So that means we have a function. We have a function. Order of growth is order of growth of F of n is less than or equal to order of growth of G of n. That much is known. That much is known. Now, does it imply that if I take logarithm here, log of F of n, it is order of growth of log of F of n, is it less than or equal to order of growth of log of G of n? So that is a question now. That is the question. So when the two functions are given, whatever operation we perform on that log operation, if we perform, whether the value changes. Whatever example you want, you can take. For example, n square you take, here it is say n cube. So it's simple logic. No, if A is less than or equal to B, whether log A will be less than or equal to log B.
Log of n square is less than or equal to log of n cube, sir.
Yes, madam. So is there any doubt here? Is it true or not? A less than or equal to B, log A less than or equal to log B.
That this fourth one is not clear. Can you explain it a little bit? I mean, I'm not getting it.
Okay, I'll take a new sheet and then.
Hmm.
So F of n is big O of G of n. then log of f of n is equal of log of g of n. Log of g of n. That is, if this implies this, is this true or not is our question. So now if I take any polynomial function, that is like n square, n cube, n power 5, or something, anything if I take, whether this both fn and gn are polynomials, whether it holds or not, that is n cube, n power 20 order. This is everything is with respect to order of growth. Okay, order of growth. Now if we take log order of growth of log n cube less than or equal to order of growth of log 2 power 20 n power 20. N power 20. Is that correct? What is its order of growth? It is same as
3 log n
3 log n.
to 20
Order
log
of
n.
growth is
20 log n. Order of growth of 20 log n.
20 log n. Order of growth of this is less than or equal to order of growth of this or not? Is there any mistake here?
This. No,
Any
sir.
polynomial you take,
Sir, what if gn is equals to 2 raised to power n? Then how will you go?
Okay, so f of n is
N
f
cube.
of n is 2 power n.
Okay,
G of n, this also something like this. Okay, it should be more. No, so 2 power 2n. Let us take something. Is that correct, madam? Do you want me to take something like this?
Yes, but sir, fn must be n cube here.
Which side you want me to take n cube?
fn must be
Fn should be n cube.
Yes, sir.
N cube. Now, if we apply logarithm, now we know that it is like this. Everything is whatever I am writing. No, it is with respect to order of growth. If log n cube, log 2 power 2n, log 2 power 2n. This becomes 3 log n.
2n log 2.
2n log 2. Log 2 means it is constant. So now this is log n. This
N
is n.
more, sir. Order of growth of n is more.
That means the condition is satisfied now.
Yes, sir.
Yes,
Yes,
sir.
sir. It is clear
Okay.
now. Thank you, sir.
Any exponential functions you take, whether it is satisfied or not.
Yes, sir. With
That is the
exponential and polynomial, it will satisfy with both.
So we can say it as true. If we want more explanation on this, after discussing formal definitions of asymptotic notations, we can even discuss proof also. Okay. Now we have knowledge about only informal definitions of asymptotic notations. With that knowledge, we are able to almost determine whether given thing is true or false. Okay. Now, so after once we learn formal definitions of asymptotic notations, if we based on that proof also, we can easily prove this. That okay? Okay. So now let us take whatever any polynomial you take. Say let us say fn is something like sigma n is equal to 0 to k equals to 0 to m ak into n power k. Ak into n power k. That means what? Fn is a0 n power 0 plus a1 n power 1 plus a2 n square plus and so on am n power m, where am is not equal to 0 and it is positive. Is that okay? Where am is greater than 0. Okay. In this case, if this is given, if f of n is like this, it is given, Then I'll write different expressions. You tell me which is true, which is false. Then f of n is big O of n power m. F of n is little o of n power m. F of n is big omega of n power m. F of n is theta of n power m. And f of n is little omega of n power m. So what is given to us? It's a polynomial whose degree is
M.
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 N
Yeah.
raised to n.
Okay. Now, now we are saying, and we know that this coefficient is not zero. This coefficient is not zero. Okay, that much is given to us. Now, based on this, can we say that f of n is big O of n power m? Big O of n power m.
Yeah, it is true.
For that, first we need to know what is the order of growth of this. What is the order of growth of this f of n? What is the order of growth?
N to the power m.
So drop all lower order terms. What are lower order terms here? This is lower order, this is lower order, this is lower order, and so on, all are lower order terms. What is highest order term here? What is highest order term?
N to the
this,
power
this
m.
is highest order term. In this, are there any constants in the highest order term? Am is a constant. Am is a constant. So finally, what is the order of growth of f of n?
N to the power m.
N power m. N power m. We know that order of growth of f of n is n power m. Now, f of n is big O of n power m. Is this true or false?
It's true.
Now, immediately, this once we know what is the order of growth of given function, then it's a fact. It's in a matter of second. We need to decide whether it is true or not. Is it true?
Yeah, it is true. Second. The second.
Second is false.
Yeah,
Okay.
second false. Third, fourth right. Fifth one is false.
Is there any doubt in this?
No doubt.
So if that means if we are given any if t of n is in the running time, no, if we are given anything 20 into n cube minus 20 into n power 8 minus 30 into n power 7 plus 6 into n power 6 plus 3 into n power 5 plus 4 into n power 4 minus 300 into n cube, something like this it is given. What is its order of growth? What is its order of growth? What is its order of growth?
N power 8.
N power 8.
That is the degree of that polynomial, no? N power
Yes, sir.
degree of that polynomial. What is degree of this polynomial? 8.
8.
So it is n power 8. Is that correct?
Yes, sir.
Is that correct? So finally, anything is given, we find what is its order of growth. After that, we can play with these asymptotic notations. Okay. These are like the alphabets of this course. Alphabets of this course. Is this clear?
Yes, sir.
Okay. Now, so one more example, say we have 4 functions such that f1 of n is big O of g1 of n and f2 of n is big O of g2 of n. Okay. Then or it we can simply say implies f1 of n plus F2 of n is big O of maximum of G1 of n, comma G2 of n. G2 of n. So assume that all four functions f1 and f2, f1 of n, f2 of n, g1 of n, g2 of n, all are functions. Okay, no functions. Then f1 of n plus f2 of n is big O of maximum of g1 of n, comma g2 of n. Is that true or not? Or why it is required? No, what does it mean is, say we have an algorithm. We have an algorithm where input size is say n is input size, n is input size, and there are two parts in the algorithm. Up to this is say one part. Up to this, someone has represented what is the amount of time it takes from starting to this, and this is second part. This the amount of time it takes is, or number of operations performed or amount of time it takes is f2 of n. Now what is total time this algorithm takes? What is the total time this algorithm takes? Or total number of operations performed in this algorithm? What is total number of operations performed in this algorithm? First number of operations in first part plus number of operations in second part, no? Number of operations in second part, which is nothing but f1 of n plus f2 of n. This is total number of operations performed in our algorithm. Is that correct? Algorithm has two parts where n is input size. So first part, the number of operations up to this someone has calculated and they represented it like this. Number of operations performed is order of growth of number of operations performed is either equal to g1 of n or lower than g1 of n. Similarly, second part is calculated like this. Then finally, whether this sum is it same as this? That is question now. Is it same as this?
Sir, I think it will be true only when F2 is also equal to the order of G1n.
F2 is equals to, madam?
F2n is equals to big O of G1n. Only then it will be true. I guess.
This is true, no? Because when we go,
okay, I'll elaborate on this. Okay, so first part, the amount of work done is say 2n square plus 3n plus 4. This many operations are performed. In the second part, number of operations performed is say 4n cubed minus 7n plus 3 log n plus 5. This is number of operations performed in second part. That means f2 of n is this, f1 of n is this. Someone has represented this as big O of whatever you want to see, simply big O of n square. Is that okay? This second part, this is only exclusively for second part. This is second part. Second part, it is represented as big O of n cube. Big O of n cube. Big O of n cube. Now, combiningly, so that means what is total number of operations performed here? Total 4n cube minus 7n plus 3 log n plus 5 plus 2n square plus 3n plus 4. This entire thing, is it same as big O of maximum of n square comma n cube?
ఈ చిన్నవి తెప్పించండి పెద్ద పోతే మొత్తం పోతున్నాయి.
Is it same as big O of n square maximum
Yes, sir.
of n square comma n cube?
Yes, sir, it is.
So that means it is simple. If there are two parts in the algorithm, if you can understand like this, if there are two parts, first part the amount of work done is big O of n square or big O of g1 of n. second part amount of work done is not more than G2 of n, not more than G2 of n. What is the total work done in this algorithm? Whether it will be smaller than G1 of n, whether it will be smaller than G1 of n, total amount of work.
Yes, sir. मतलब minimum
Whether
of
it will be
n
smaller.
square.
See, there are two parts. Okay, no, there are two parts. Here it is 20, here it is 80. Total value 20 plus 80, whether it will be smaller than 20 or whether it will be smaller than 80. What is that we can say? We can say that it is
Greater than 80. The
it is
total
greater
value
than
will
or
be
equal to
greater
2 times 80. Easily we can say what is this 80?
Yes, sir. Yes,
2
sir.
times maximum of 20 comma 80. 2
Yes, sir.
times maximum of 20 comma 80. Is that correct?
Yes, sir.
That means what is its order of growth now? This 20 is say F1 of n, 80 is F2 of n, okay. So what does it mean? It means F1 of n plus F2 of n's order of growth is less than or equal to 2 times, 2 times, 2 times, 2 times order of growth of maximum of F1 comma F1 of n comma F2 of n. Is that correct? Even this much also is not required. Here directly, are you able to see this or not?
Yes, sir. It is true then. Yes, sir.
See, there are two parts. First part take not more than this much amount of time. Second part doesn't take more than this much amount of time. Both parts together, what is the amount of time it takes? Is it less than or equal to the more amount of time taken in larger part? Correct? No, definitely it is like that only. It is true. It is true. It is true. Okay, so if you are interested in this, again we can prove it. We can prove it by using formal definitions. Formal definitions are useful for showing this type of relationships. Okay, now formal definitions are useful for showing this type of relationships. Okay, let us start with what is formal definition of formal definition of big O notation. Formal definition of big O notation. Big O notation. So what is formal definition of big O notation? So let us say as usual, f of n and g of n are what type of functions? Here we assume that they are monotonically increasing functions. They are all positive. There are positive functions. Now, when do you say that f of n is big O of g of n? When do we say that f of n is big O of g of n? That means order of growth of f of n is less than or equal to order of growth of g of n. No, order of growth of g of n. That means, so one side f of n, the other side we have g of n. Other side we have g of n. So f of n, its order of growth is n square. Okay, whether it is 3 into n square or it is 4 into n square or 20 into n square or plus whatever, these are smaller terms. Whether it is 50 into n square, whether this a constant matters, constant of this n square, whether it matters?
No.
No. Okay, similarly, it has some order of growth. Say n cube. Whatever constant we get, whether it matters here.
No.
Whether it is 20, 40, 30, 300, something like this, it doesn't matter, no? So ignoring this constant, or we can say that numerically it is less than or equal to this. Numerically it is less than or equal to this. If at all we are able to find constant such that this value is numerical value is less than or equal to numerical value here, so that we can select some constant here. So that I will say. So that means if at all we are able to find the constants C and N naught, say C and N naught, such that okay, f of n is less than or equal to C into G of n for all n greater than or equal to n naught. For all n greater than or equal to n naught. Okay, I'll tell you what does it mean. What does it mean? Okay, let us take first. Here we are going to compare numerical values. F of n numerical value, C into G of n numerical value. C into G of n numerical value. Now if I plot it, one side n value, other side this function values f of n, g of n. This is say 0. This is one axis. This is other axis. From n naught value or more onwards, this is say somewhere n naught is there. Somewhere n naught is there. Okay, somewhere n naught is there. From n naught value onwards, what does it say? If f of n is something like this, what can you say about value of g of n? C into g of n, numerical value of C into g of n. What can we say about numerical value of C into g of n?
It may be lower before n less than, but later on it would
What
be.
is the condition given here? Condition given here is from n naught. From n naught, what is the value, numerical value of C into g of n? C into g of n. It is greater than or equal to f of n or not? Is it greater than or equal to f of n or not?
Yes.
Yes. So in the diagram, what if I draw curve for C into G of n, it comes above this f of n or below it is f of n curve?
Below the. No.
So here it will be 3, 4, 5. 3 is here means 4 is the more means it is above, no?
Above the line, boundary line.
Okay. So it comes something like this. So this is not G of n alone. It is C into G of n.
G of n. Okay.
C into G of n. But values which are smaller than n naught, we don't know. Values which are smaller than n naught, we don't know which is more, which is less. One may be something like this. The other one may be something like this. Something like this. That means we don't know. It doesn't matter to us. It does not matter to us. It does not matter to us. Below n naught, this is input size when you consider n naught. From n naught onwards, this is the relation between f of n and C into G of n. This we will see with an example. So we know that standard this n into n plus 1 by 2 is big O of n square. Is this correct or not?
Yes.
We know that it is true. Now, how to show this? If you are asked to show that n into n plus 1 by 2 is big O of n square. How to show this? Then this formal definitions are useful. Okay. So now what is f of n here? What is f of n here?
N into n plus 1 by 2.
So it is 1 by 2 into n square plus 1 by 2 into n. 1 by 2 into n. What is g of n here? N square. In order to show this, what is that we need to find according to inequality given in 1? What is that we need to find? We need to find two constants C and N naught. We need to find two constants C and N naught. Is that okay? So that is f of n 1 by 2 into n square plus 1 by 2 into n less than or equal to some constant we need to find into less than into n square. For all n greater than or equal some other constants we need to find. We need to find. Is that okay? Now you tell me what is the value? N is input side. What are the values n takes? We know that it is 0, 1, 2, 3 like this. Okay. Now what is the value that I need to choose for C? This is C value. This is N naught. So that this inequality holds. This inequality holds. For example, C equal to 1 by 2 if I take. C equal to 1 by 2 if I take. C equal to 1 by 2 if I take. Whether it becomes true for any value of n, whether it becomes true for any value of n, C equal to 1 by 2 if we take, whether it becomes true for any value of n or not.
No.
No, sir.
Why? Because this side we have 1 by 2 into n square plus 1 by 2 into n, which is where n is positive. No. So definitely this quantity is more than 1 by 2 into n square. So definitely from this it is clear that C value must be greater than 1 by 2. Greater than 1 by 2. Greater than 1 by 2. So we also know that 1 by 2 into n is less than or equal to 1 by 2 into n square. 1 by 2 into n is less than or equal to 1 by 2 into n square.
మొదటి కండిషన్ ఏంటంటే someone is మా అబ్బాయి పెళ్లి 15 రోజుల ముందు అడుగుతా someone's mic is not
All the participants to keep your microphone in mute.
రెండో విషయం ఏంటంటే మీ బామ్మర్ దగ్గర నువ్వు రాంచుకో నువ్వు నాకు రాసి వాళ్ళు రాను.
Sir, we can't control that. We can remove the participant or something.
I think now it's stopped now. I think now it's okay. Now from this it is clear that C must be greater than 1 by 2. C must be greater than 1 by 2. Is that okay? Is that okay? Okay. Now 1 by 2 into n is less than or equal to 1 by 2 into n square. Is that correct? Now we know that 1 by 2 into n
Sir,
square
your
is
voice
same
is
as 1
breaking,
by
sir.
2 into n square. 1 by 2 into n is less than or equal to 1 by 2 into n square. 1 by 2 into n square is same as 1 by 2 into n square. If I combine these two, if we combine these two, then what happens? This is same as 1 by 2 into n plus 1 by 2 into n square, which is less than or equal to 1 by 2 into n square plus 1 by 2 into n square. So that is, what is that we have got? What is that we have got here? This is nothing but our quantity. No, this 1 by 2 into n square, this quantity. This is less than or equal to, what is that we are able to write here? 1 by 2 into n square plus 1 by 2 into n square. What is that value? What is that value?
1.
Which is same as 1 into n square, no?
Yeah.
So now 1 by 2 into n square plus 1 by 2 into n is less than or equal to 1 into n square. Is that correct? Is that true for any value of n? Is this true for any value of n? Is it true for any n greater than or equal to 0?
No. Still we need to find out n0.
No. 1 by 2 into n less than or equal to 1 by 2 into n square. Is it true for any value of
That is fine.
n greater than or equal to 0?
Yes.
Similarly, 1 by 2 into n square is equal to 1 by 2 n square. Is it true for any value greater than or equal to n, which is greater than or equal to
Yes.
0? The combiningly, whether this result will be true for any value greater than or equal to 0? Can we say that it is true for any value n greater than or equal 0?
Yes, sir.
So then you might ask me, why did you take here 1 by 2 into n square? Somehow I need to write it in terms of n square. Somehow I need to write it in terms of n square. Here I have seen what are the terms. 1 by 2 into n square is there. So something in terms of 1 by 2 into n square, I have written it as same as 1 by 2 into n square. Now I have 1 by 2 into n. This I should write in terms of n square. In terms of n square. So we are able to write it as 1 by 2 into n is less than or equal to 1 by 2 n square. This, fortunately, this equality is true for all n, any value of n which is positive. Is that correct? So from this, what is the conclusion? So we are able to find two constants C and N naught, C and N naught, where C is 1, N naught equal to 0, such that this inequality 1 is true or not, such that inequality 1 is true or not. Hence, based on the formal definition of this big O notation, what is that we can conclude? What is that we can conclude? 1 by 2 into n square plus 1 by 2 into n is big O of n square based on the formal definition of this notation, which is same as the given result, which is same as the given result. Whether you understood this or not? Okay, let us take one more example. See, even if you have not understood this, no problem, but questions you will be able to solve, okay, related to this. With whatever knowledge you have now, that you will be able to solve. Say n into n minus 1 by 2. Can we say that it is big O of n square? Is this true? Is this true? N into n minus 1 by 2 is big O of n square. Is that true?
Yes.
Yes. Then how to show this? How to show this? Now we know that in order to show this f of n less than or equal to c into g of n for all n greater than or equal to n naught, we need to find these two constants c and n naught. C and n naught. So now n into n minus 1 by 2 is same as 1 by 2 into n square minus 1 by 2 into n. Is that okay? So 1 by 2 into n square minus 1 by 2 into n should be less than or equal some constant into n square for all n greater than or equal some constant. Some constant. Is that okay? Is that okay?
Here we can take half. C equals
Here
half.
easily, because this value, no, we are subtracting something here. So our job is easier in this case. What is that we can do? What is that we can do? What is the C value that we can take?
1/2. 1 2. 1 by 2.
1 by 2. Is it less than or equal to 1 by 2 into n square? Is this correct? Is this correct?
Yes.
Is that true?
Yes, sir.
Okay. That means what is C value here? 1 by 2. What is C value here? It is 1 by 2. What is n naught? N equal to 0 if I take, is this true? 0 minus 0 is less than or equal to 0. N equal to 1 if I take, 1 minus 1 less than or equal to 1 by 2. Okay, no, because here direct value itself, it is numerically less, no? So we need not even check for which value of n it will be true. Okay, so I can take 0 here. Can take 0 here. So can you give me some other constants? So therefore, finally C equals to 1 by 2 and n naught is 0. Can you give me some other constants where it becomes true?
Any value higher than 1 by 2.
Any value higher than 1 by 2 if we take, whether it becomes true. Similarly, n naught If I take C equal to 1 by instead of 1 by 2, okay, simply take C equal to 3 and N naught equal to 2. Whether is it true or not? Is that true or not? Is that true or not? Is that true or not? Like this, no, we can have infinite number of values for C and N naught. Like this, we can find infinite number of values for C and N naught. But only a pair of values, no, that is C and N naught. One combination, if you find, that is sufficient. One combination, if you find, that is sufficient. Then we say that f of n is big O of G of n. F of n is big O of G of n. Okay, let us take this, whatever earlier we discussed, no, let us take that. See, if we are given if f1 of n is big O of G1 of n and f2 of n is big O of G2 of n, then f1 of n plus f2 of n is big O of maximum of G1 of n comma G2 of n. Now, so that if that is true, then this is true. Then how to solve? Okay. Okay. So now what is given here? We are given f1 of n is big O of G1 of n. We are given, what is given? f1 of n is big O of G1 of n. f1 of n is big O of G1 of n. Is that okay? What does it mean? What does it mean? What does it mean? Order of growth of f1 of n is, order of growth of f1 of n is
Less than order of growth of G1.
less than or equal to order of growth of G1 of n. So that means f1 of n, we can write it as less than or equal to, according to formal definition, some constant is C1 into G1 of n for all n greater than or equal some constant, say n1. Is that correct? Is that correct? So similarly, what is given? f2 of n is big O of G2 of n, which implies what? Here also there exists some constants, say C and n naught. That is C, I call it as C2 for all n greater than or equal to n2. Is that correct? Because if this is true, then according to the definition, it should exist. C1 and n1 should exist, and here C2 and n2 should exist. Is that okay? Okay. Now, what is f1 of n plus f2 of n now? Okay, you add this. Okay, now 1 plus 2. 1 plus 2. 1 plus 2. What is that we get? f1 of n plus f2 of n is f1 of n plus f2 of n is less than or equal to, less than or equal, less than or equal, left side and right side we add C1 into G1 of n plus C2 into G2 of n. Is that okay? Is that okay? Now, this inequality is true for, this is a axis, this is 0, this is n1. n1 onwards, this inequality is true. All values which are greater than or equal to n1, it is true. Inequality 2, it is true for values n from n2 onwards. True for values from n2 onwards. Yeah, if for example say n2 is here, N2 is here. That means for all these values, no, it is true. Now the combination will be true for which values? Combination will be true for which values? Combination will be true for which values of n?
N2, above N2. The values
Combination will be true for what values of n? Combination will be true for what values of n?
N2.
From n2 onwards it is true or n1 onwards it is true?
N2 onwards.
N2 onwards. Why? Because N2 is more. N2 is more. Here N2 is more. Now if it is 10, it is 20 or something like this. No, N2 onwards. Is that okay? So we can say that it is true for all n greater than or equal to n3, where n3 we write it as we don't know which one is more, which one is less. No, n3 we can take it as maximum of n1 comma n2. Is that okay?
Yes.
Is that okay? Okay. Now again, C1 is a constant, C2 is also constant. We don't know which is more, which is less, which is more, which is less. Let us take again C3 equals to maximum of C1 comma C2, maximum of C1 comma C2. So then what is that we can do? Equals to C3 into G1 of n plus this is also C3 into G2 of n for all n greater than or equal to n3. Is that okay? Equals to C3 we can take common. C3 we can take common. It is G1 of n plus G2 of n. Is that okay? Now what is G1 of n and G2 of n? They are positive values, no, positive functions. Okay, positive functions. So what is that we can write? If A and B are two real values, A plus B is less than or equal to maximum of A comma B plus maximum of A comma B. Is that correct? Is that correct? A plus B is less than or equal to maximum of A comma B plus maximum of A comma B. A is less than or equal to maximum of A comma B or not? B is less than or equal to maximum of A comma B or not? Now you combine these two, add these two. A plus B will be less than or equal to maximum of A comma B plus maximum of A comma B, that is 2 times maximum of A comma B. Is that correct? Is that correct? Is there any doubt? Okay. Now what is that in place of G1 of n plus G2 of n? What is that we can write? What is that we can write?
G1 of n.
What is that we can write? What is that? If it is say assume consider it as A, this is B, then what is that we can write?
Maximum of
Maximum of
G1 of n
less
comma
than or
G2.
equal to C3
And
times. Okay, no, 2 times maximum of this is plus 2
G1
times
of
no.
n.
2
G1
times
of
G1 of n
maximum
comma
G1 of n comma G2 of n. Okay, for all n greater than or equal to n3. So it is of the form. So finally we have got this f1 of n plus f2 of n is like this. Now if we look at this entire thing, I can consider it as some constant. This is another constant. It is of the form f of n is less than or equal to some constant to c into g of n for all n greater than or equal to n3, n naught. Is it of that form or not?
Yes, sir.
Is it of that form or not? where f of n is this, g of n is this, c is this quantity, n naught is n3. So therefore, what is that we can write? If it holds, then what is that we can write? Therefore, f1 of n plus f2 of n is which is nothing but definition of big O notation. No, definition of big O notation is big O of maximum of g1 of n comma g2 of n. That's what we discussed. No, actually it is true. Even we need not do in this case, no, this entire thing. Okay, so this example, this result easily we can observe based on order of growth without actually going for formal proof. Okay, because in competitive exams, no, we are not going to prove it something like this, no, every time. Is there any doubt here?
No, sir.
Okay. I stop here. Okay.
Sir, PPT, sir.